All right, coming to you live, doing a little late night recording. So here we go. Hey, we're going to talk about perpendicular lines. Yesterday we did parallel lines. So starting off with a quick little warm up here. If I were to ask you to graph a line, and I just kind of you assume it. So I want to make sure that we feel pretty good about that. There's the line. There's some important information. Right there is the y-intercept. The y-intercept right there. So we can just take one of these points, move it to the positive 2, and we know that that is the y-intercept. Now, this right here is our good friend, the slope. So remember the slope is 4, but it's really 4 over 1, and that's rise over run. So when you know where your y-intercept is, what you do is you count from there your rise over run. So 1, 2, 3, 4 is the rise, and then 1 is the run. Once you have 2 points, it is pretty darn easy to connect those points, especially when you have a line right there waiting for you that's going to work out perfect. So that's a quick little review on how to graph a line. All right, today we're all about perpendicularity on graphs. What does it take for two lines to be perpendicular? First of all, what is your gut? Do you remember what perpendicular is? Yesterday we talked about lines like this, and those are indeed parallel. These right here, they look perpendicular, and perpendicular is going to be when two lines meet at 90 degrees. 90 degrees. Love it in the house. We love it when walls are straight up and down or perpendicular to the ground. All right. Here's another view of two examples, once again parallel. And yesterday we took it to the next level and we really talked about the slopes being equal. And that's how we know it mathematically or algebraically or geometrically even, that those two lines are indeed parallel. They both have a slope of 1/2. Now notice when we have perpendicular lines, we do indeed have 90 degrees, but there's something cool about the slopes. And that's what we're going to discuss today is what do we know about the slopes of perpendicular lines? If you just kind of look real quick, that slope is 1/2 and that slope is -2. So when you compare the slope of 1/2 versus the slope of -2, there's kind of a cool relationship between those two slopes. If I did about 10 more, I think you would be like, oh, it's always this. And we're going to jump to that conclusion and say that yes, when we talk about perpendicular slopes, we are going to say that the fancy terminology is opposite reciprocal. An opposite reciprocal. Well, basically what an opposite reciprocal is, let me move me out of the way if I can. Basically what an opposite reciprocal is, if you have a slope of m equal to AB, then all you do is take that A and B, you switch them, and you flip the sign. If it's positive, we go to negative. If this was negative, we go to positive. That's it. So let's just practice. Let's say we did a lot of work, we found some slopes. The first slope is 3/5, so the opposite reciprocal of that is you switch them, and you can make the bottom one negative and not the top one, but it's more conventional just to make the top number negative. Sometimes people write this as the negative is kind of out front of the fraction, and that's implying the top number. All right, 1/2, you switch them and flip it. Cool. When you're given just a number, go ahead and put a 1 under there to make it easier, so then you have two values to deal with. So we would switch it and flip it. And unfortunately, I only have one example of it being a negative slope. So, you're like, well, which one's negative? Doesn't matter, because you're going to switch it and you're going to flip the sign. So that negative becomes a positive. So that's what we mean by switching or flipping the sign. That's it. So if I had a slope there and a slope there, I would know that those two lines are perpendicular. If I had those two slopes, those two lines would be perpendicular. All right, so obviously you're going to be asked, given these two lines, do we know if they are parallel, are they perpendicular, or are they neither? All right, so I'll remind you, if they have equal slopes, they are parallel. If the two slopes have that opposite reciprocal notion, they are going to be perpendicular. And of course, if they don't have it, they are neither. So here we go through this, and the slope here is -2. The slope here is -2, and we would say these are parallel. They have the same slope. That's all there's to it. I don't know what they look like. I'm not asking to graph them. I'm just saying, hey, I know my heart and soul that those bad boys are parallel. So we look at this. The slope here is, the first one is equal to 2, and the slope here is equal to -1/2. So 2 and -1/2, maybe it would help out if I wrote this over 1. If I take one and switch it and change the sign, do I get the other one? Absolutely. These are perpendicular. The symbol for parallel is two vertical lines like that. The symbol for perpendicular is two little lines meeting at 90 degrees. All right, are they always this easy? Maybe. Let's check it out. Here's our two lines. All right. It's going to jump on me a little bit. So, you know, obviously the slope here is equal to -5/3. But a lot of the times, you're going to have to work for that y = mxb form. Wow, that is really jumping. Not too sure. Okay, let's just check it out, see if that works. All right, so what we have to do is make sure we get it into y = mx plus b form. I'm going to add 3x to both sides. I'm going to divide both sides by 5, and I get y = 3x. All right, y = 3x. Wow, that's really jumping around. I'm sorry about that. So let's just make this go away. The slope there is 3/5. Let's compare slopes. Oh, that's just nauseating. Just nauseating. So we have the top one is -5/3. The bottom one is 3/5. Are they the same? No, they're not parallel. Are they opposite reciprocals? If I take one, flip it, and change the sign, will I get the other one? Yes, these are perpendicular. Absolutely. Well, we're not going to make the same mistake on this one. Maybe. I'm just going to make this go away. Let's just look at the whole problem. All right, the slope here is obviously 2/5. The slope here is 5/2. I had to do a little bit of work here. I had to divide everything by 2. Remember, when you're dividing by 2, to get rid of that one, you got to divide everything by 2. This slope and this slope, they are not equal, so they're not parallel, but they look like they might be perpendicular, but they indeed flipped, but they didn't change signs. These are both positive, so this is a neither. It's close. It's definitely close, but it's not there. All right. So you're going to give a picture tomorrow, and or today, whenever you look at this video. And if you're given something like this, then the first thing you got to do is find the slopes of all the lines and then compare them. find the slopes of all the lines and compare them. So when we do that, just slide that sucker over here. The way I notated this was this is the slope of line C. It's also in green, so it's easy to read. Well, Mr. Sayers, how did you get that? Well, I just went from this point to this point. So I counted 1, 2, 3, 4, 5, 6, 1, 2. So that is a rise of 6 and a run of 2, and that reduces 3 over 1. If you want to verify, I did that for all 4 lines. So now I need to compare those lines and see which ones are equal, which ones are opposite reciprocals. All right. Hopefully you can see that. I need to go somewhere over here. These are the same slope. So if they're the same slope, they are parallel. So we would say lines C and D are indeed parallel. This negative 1/4, this blue line, it's awesome, but it's not the same and it's not the opposite reciprocal of any line. So we would say line A, or the blue line, is neither parallel or perpendicular to any of them. Now notice this negative 1/3. This negative 1/3 is the opposite reciprocal of that one and the opposite reciprocal of that one. So if they have that relationship, they are perpendicular. So I'd say that line B is perpendicular to C, and I'd say line B is perpendicular to D. So what we know here is this is 90 degrees and this is 90 degrees. Awesome. All right, now we're going to get into it a little bit. Need you to, this is the one you want to make sure that you have pretty good notes. I'll try to get myself out of the picture as much as possible. So now we're writing the equation. We're going to write the equation. This is what we've been waiting for. This is why we came to school today. This is, we're getting our money's worth. We're write the equation. But instead of a line parallel, we're writing one perpendicular. Here we go. We're given a line and we're given a point. All right, I'm really going to write this one out for you. If you want, you slow down and take notes. First, the question you ask, is it in y equals mx plus b form? It is. So we can look directly at it and say, hey, I know the slope. The slope is 3. Sometimes you want to write 3 over 1. Second, so it's perpendicular. We're not going to use the same slope. We're going to have to do something to that slope to create the slope of the line perpendicular. So what do? We do the opposite reciprocal, or we flip it and switch it. So the reciprocal of 3 over 1 is we flip it, put the 1 over the 3, and change the sign. If it was positive, let's make it negative. Now we have our new slope. We are ready to move on. Write a new equation with what information we do know. So now we know the new slope. We don't know the y-intercept. So just like yesterday, we get to the point of y equals the slope that we want times x plus b. Well, nothing changes from yesterday. Now we plug in that point and we figure out what that b value is. We plug in that point and we figure out what that b value is. All right, let's remember the point is negative 6, 1. That is our x, that is our y. So everywhere I see a y, I put a 1. Everywhere I see an x, I put a negative 6. I plug that in. A negative times a negative is a positive. Some people get a little nervous. They've got a fraction and a whole number. The whole number is really over 1. So we can multiply that, get 6 over 3. 6 over 3 is 2. Subtract 2 from both sides. And we get our final answer. Wasn't that cool? We're done, but of course we want to check it and make sure it's right. So we can just slide this sucker down and let's test it. Just get rid of that. We can graph both of these. 3x plus 4 means we go to 4. The rise is 3 over 1, so up 3 over 1. And luckily I have the perfect line already made, so that's going to be something like that. And the other equation has a y-intercept of -1, and from there a rise of -1 and a run of 3. So there's our 2 points. I have this. That's roughly there, and sure enough those look pretty darn good. It's looking perpendicular. Alright, so what I've done here are 2 more examples, and this is for you to kind of check out and go through if you need it. I'm going to do that real quick and one at a time, just walk you through what I thought about. I did both examples, parallel and perpendicular, to kind of compare and contrast the methods. Man, pretty straightforward. We start out, is it y equals mx plus b form? It is. So I know that the slope is -3. Not too sure why it's so jumpy today. All right. And then since it's parallel, that's the slope I want to use. So I plug in -3. And now I'm going to plug in my point. The x is 3 and the y is -1. Solve for b and I'm done. All right. If I want to look at the way to find an equation perpendicular, then I'm just going to see if it's in y equals mx plus b form. It is, so my slope is -3, but since it's perpendicular, that's the key new step. Now I take that slope, flip it, switch the sign, and then that's the one I'm going to use on my new equation. Everything's the same. Plug in the x and the y, solve for b, I got b equals -2, and I am done with that problem. I don't know if that's enough, so I did another example. This time the equation wasn't quite in y equals mx plus b form, so I walked through the example talking about please put that in y equals mx plus b form. You do that in both methods, whether you're doing parallel or perpendicular. How do we know x equals 4 and y equals 2 are perpendicular? Well, hopefully you're paying attention yesterday and you know that any equation x equal to 4 is going to be vertical, and any equation y equals 2 is going to be horizontal. So what that would look like is maybe x equal to 4 and y equal to 2. Those two lines are going to be perpendicular. There's your assignment. I'll put it on that clever.com so you can go through there. I don't know if clever.com is going to allow you to do these, so since I gave you just such a little set, I would prefer that you wrote it out, took a picture, and showed me you could do that, because these require those steps. So let's do that. So no clever on this one. I want to see work. Hey, there's nothing that those examples are not going to help you with, so just kind of walk you through that. I'll be here to help you out. All right, adios.